Morning. I wish you all to fill this with loads of hopes and smiles. Dear professors, I welcome you all for the AICTE-ISTE sponsored 6 days refresher course on Anaconda Data Science Techniques. The agenda for the day contains 3 sessions. First session will be on data visualization with using Matplotlib and Seaborn. And the second session will be on art of living. And the last session of the day will be on basic statistical analysis using Python. Without further ado, let's get started. Session 7 will be on data visualization using Matplotlib and Seaborn. It will be handled by Mr.Sudharsan. I feel glad in introducing the resource person to the gathering. Mr. Sudharsan is a software specialist, cloud sales and services at L&T Infotech. He is a techie with proficiency in resource, finance, project analysis, and planning. He has collaborated with clients such as Terex and Marsh and McNamara Groups in account payables, automation, insurance, and manufacturing. His areas of expertise include Eclipse, Tableau Desktop, JDeveloper, WebLogic Server, Oracle, and MongoDB. He is a certified analyst in business management and process management. He is also a certified corporate communication professional. It's an honor to have you with us today, sir. I now request our resource person, Mr. Sudharsan, to take over the session. Over to you, sir.
Thank you so much, ma'am, for giving this nice introduction. Okay, let's move on to the content. Good morning, all. I hope I'm audible to everyone, I guess.
Yes, sir.
Okay.
Good morning, sir.
Good morning, ma'am.
Good morning, sir.
Good morning, sir. Let me share my screen. Is my screen visible to all?
Yes, sir.
Okay. Okay, I need not give any introduction about myself because the man has given me a wonderful introduction. So let us go straight away to the contents which we are going to look into it today. Like these are the basic, overview. Like what are the things which we are going to look. We might initially get start up with like basics of data visualization, like what it actually means and what is the need for that, and what are the types of data visualizations which we can create. Then what are the libraries which we use for creating such visualizations using Python, and what are the characteristics of that, like what are the things which we can get out of those libraries. And here, as per the requirement, we have come across with we have come up with two libraries, Matplotlib and Seaborn. Later, like we can compare the same thing, like a difference between ETL and tailor-made tools. Like for example, how does this Matplotlib works in comparison with other ETL tools? Both are going to do the same visualization, like what we are going to get some kind of graphical representation using Matplotlib libraries. Similar things we can get in other ETL tools like Tableau in combination with Informatica, like that, those things. Then like how the visualization should be seen from a techie's perspective. That could be the like summarizing part. Okay, so you all know like what is data visualization is all about. Like instead of reading a big report which is having numbers, letters, characters, those things, instead of that we can just go through like what is happening. With the help of a graphical representation, maybe like a pie chart or through a line graph or a bar chart, something like that. With the help of that, we can understand easily the idea which the presenter tries to conceive to us can be understood very simple way. In a simple way, like it will not take much time to understand. Then it will be very easy to categorize. For example, like if you're going to get data for about 1,000 records, records in the sense like 1,000 rows in an Excel file, for example, or in a database table. But it is all about for example, it is all about 4 states means. Then we can categorize like for state A, how much records is there. For state B, how much records are there. For state C, how much records are there. Like that, we can easily categorize them, so that it will give an opportunity for us to analyze those details in a better way. Then if we categorize them like that, then we can quickly interpret like what is happening, how the data is behaving with respect to particular period of time, like that. Then obviously we all know that data will be the next source that will keep running the world. Okay, so what is the need for data visualization? Actually, we used to make the need of a data, we used to describe it in a 6P method. 6P are like a prevalence, possibilities, prediction, proximity, precaution, perfection. Sorry. You all, based on this name itself, you can figure out like what is it all about. Prevalence means like the thing that is currently existing. For example, the sales market, sales data. For example, it has what amount of sales has happened between the last, in the last decade, like between 2011 to 2020. That is prevalence, like existing data which we have. There are no changes going to happen in that record because it has already happened. Okay, so possibilities are nothing but like what are the things that can happen. For example, the sales between 2011 to 2020 might not be the same in 2021 to 2030. It might differ, and in that condition we can figure out like what are the possibilities in which way the sales might happen. The sales might increase, sales might decrease. There can be many reasons, like festive season. During festive season, the sales might increase. Non-festive season, sales might decrease, and the cost factor might increase. Due to that cost factor, companies might require to give some discount, those things and all. Based on those factors, we can find some possibilities in the sales. Then prediction. Out of these, after analyzing all these factors, we can predict something like this is how it might happen. It is not a concrete thing that will happen. It might happen like that. So filtering out the expected cases. Expected cases might be might be 100, but prediction might be within less than 100. Maybe it should be around some 10 or 15, something like that. Then proximity is like minimizing the C pages. Like out of our prediction, we can't be 100% sure like whatever we have predicted will happen. There might be some deviations. Such deviations are called as C pages. C page means like missing out, like flowing out. For example, C pages is something like erroring of condition, like negotiations. That is how we used to term it. Then comes a precaution, identifying the loopholes. After identifying the C pages, like wherever the values got deviated, we need to find out what is the actual reason for that. And then based on that factor, based on that information, we need to increase the bandwidth. If we increase the bandwidth, like we can minimize those C pages as well. Then comes perfection. Perfection is nothing but like we need to make sure like whatever we have predicted should be in par with whatever will happen in future. That is 100% is not possible, but we need to make it as we need to increase the percentage of that. Okay, so like types of data visualization, like these are the various types in which this data visualization can be classified. Okay, like first, the state oriented. For example, if you're going to give a report which you have generated to a person or an end user, if that user can access your report, a report or a dashboard, something like that, in an interactive way. For example, if he can give some values to the dashboard, and if it returns you change with new data, after refreshing with the user's input, then it is called interactive. Else, if it is just going to give you a report or something like that in a graphical way, then it is static. In that, the user cannot do any operations. Then comes continuous and discrete. This is actually data-oriented thing. Like, for example, as I said before, the sales data from 2011 to 2020. If it is continuously available for the entire 10 years, then it is continuous. if it is not available for those entire 10 years, for example, it is available only for 2 years, like between 2011 to 2013, 2000, I mean, yeah, 2011 to 2012, then 2015 to 2016. If it is like that, in between 2 to 3 years, you might be missing. In that case, like you need to check, okay, like we don't have data for this period of time, so this cannot be a continuous thing. So it will come under discrete. These are actually statistics concepts. Then comes individual or combinational data. Individual or combinational data means like you can compare, for example, you're going to compare the data of speed and distance covered within a particular period of time. Then you can have a same graph, and you can just change the scale for speed as well as distance covered with respect to time. Then comes dependent and independent factors. Dependent, as I said in the CPH concept, like there could be some deviations in your prediction. In that prediction, we need to identify what is the reason behind such CPHs. I mean, we need to find out what are the factors that are causing those deviations. After finding out those factors, then we need to find out whether the variable, for example, this time factor or speed factor. For example, in an ideal road condition, speed should be directly proportional with respect to distance covered, but there might be some conditions like that we might face some speed breakers, humps, something like that. Even the road might not be good enough to travel. In such cases, distance covered might not be directly proportional with respect to speed. In that case, speeds might have a spike in the graph. So in that case, the factor is the road's nature or the road's characteristic. So these are factors oriented. Then comes cumulative and split. Sometimes the data might be very high, like a very huge bulk data. In that cases, like we need to split the graphical representation, else the graph which you have got might be too clumsy, like you will not be able to interpret what is actually happening in the data. So it will be better to split the data into parts. For example, if you have data for last 10 years, then you can split the data for first 5 years and then for next 5 years, so that it will be more legible for you to understand like what is actually happening in that data. Then comes expandable and shrinkable. Okay, so these are like this is actually a perspective view. Like for example, if the person wants to find the data for last 10 years, means he can see. If he wants to find the in-depth data, like he want to increase the granularity, means like if he wants to see the data for 120 months, for example, earlier he was able to see only the year-based data. Now he can even view the month-based data. Like for before, it will be showing like 2011. You can see find this much amount of data. Later, you can expand it to 2011 January, 2011 February. Like that, you can go in depth, increasing the granularity. Granule means like level of the data will be increased. Okay, so let us go into like using these libraries. Like not only these two, we have many more libraries available for plotting the graphs in using Python. But basic libraries are like Matplotlib, and Seaborn is actually kind of like CSS kind of thing. For example, if you are creating a web application using HTML components, we might be using the CSS concept, and the CSS concept is to beautify that. Seaborn is similar kind of that. Like it actually works based on this Matplotlib functionalities, but it will improve the look and feel. So let us first go through this Matplotlib libraries. Okay, it is actually a 2D representation. It will not provide a 3D graphs, and the quality is not much appreciable. Much appreciable. Like it will be having just low-level graphics, and it is an open source, so it can be used by anyone. Like it may not, it doesn't require any security key or something like that. And one more thing is like this Matplotlib gives an opportunity to work on images. For example, if you want to convert an image, a colored image, into a grayscale or black and white, it has its own libraries. Its own function to do that. And these are the different types of charts which we can create this matplotlibs, but they are not, it is not limited to this. There are more other options available. So let us go with an example so that you will get a clear picture. So this is a sample data set which I have created. Actually, this is like runs code by Sachin against each and every playing nations. Before that, is there anyone having any doubt in the theoretical part? Hello. Hello.
No doubt, sir.
No doubt. Okay, good. Okay, so like let us create a sample visualization using this NumPy plot. I mean Matplotlib. Okay. And one more thing, like if you are going to work on these libraries, then obviously you must be aware of the two already existing libraries like NumPy and Pandas. If you're going to work on Excel, these are actually scikit. This is actually optional, but it will be used only in few cases. Okay. So like with respect to this data source, let us create a simple data visualization. Put NumPy as NP. Input pandas. This is NP. This actually NumPy library gives us an opportunity to use various methods. It will give reduce the code complexity. We need not type a number of lines. It has an enormous number of functions which we can use.
Sir, if font size can be little bit increased or little bit zoomed, sir.
And I'll type in Notepad plus Notepad, and then I'll copy it here. Is this fine now?
Yes, sir. Yes,
Still,
sir.
I'll increase. Okay. So we are going to fetch data from this data source. So like it will be df. Df is as nothing but a data frame. Like we are going to collect the entire data within this column as a frame. Like a frame is nothing but a set. For example, if you are going to deal with a list, you might be aware of these data sets concept like a list, set, tuple, then dictionary. Here we will be collecting all this data in a list kind of thing, which is nothing but a frame. Data frame is a concept that is existing in NumPy. That is why we are using this NumPy library. It is going to collect data of the countries. Equal to pd dot read underscore excel. We're going to dot xlsx. Then comes sheet underscore name equal to, let us say Satin. Use false equal to okay. print df. For example, if I execute this query, I mean this code here, let me save it as what is the name? Actually, Matplotlib. Pandas PD. Okay, sorry. Matplotlib. Once again, import numpy. Something went wrong. We need to figure out that. If countries. Read Excel. Then you can collect the data of runs. Read underscore Excel. Column name alone is going to be different this time. Now we are going to collect the data frame of average. Read underscore Excel. Okay. Later we can store the data array format, like array. Countries. Data frame of countries dot values to list. This is the, I mean, the reason why we are going to convert it into list means this will be in the form of an object, like whatever the data that we are going to fetch on to this variable through this method will be in the form of an object. So we need to convert those objects into a list. So we are converting here into converting those object values as a list here. After converting to list, it will be of n-dimensional data. So we need to flatten it to make it as a single dimension data. after converting it as a single dimensional data, we need to convert it as a, yeah, fine. It will be converted to a single dimensional data. Similarly, we can get the data for ynp dot array df runs dot values dot to list dot flatten is it equal to np dot array df averages dot values dot to list. Again, it needs to be flattened. Okay. So now we are going to plot it. Dot x comma dot show. Let us now try to execute this. It is saying some is not a package. Existing, so it's not an issue. Okay, fine, no issues. Like both are same data. Let us make it as Z. Okay. Python filter. It's fine. Okay, so now it has got the data in the form of a list. For example, it has first list is countries, second list the runs scored against each and every country's their respective way. Then comes average of runs against each and every country. Okay, so now let us try to plot. Something went wrong. I think Matplotlib start working in my machine. Let me close and reopen. Okay. Matplotlib. One second. What's happening here? Module not found. Why? What's happening? Matplotlib dot pyplot. SPLT. Uh, Actually, I think Python has got corrupted information right now. How to proceed? Executed them. It's actually sorry for the inconvenience that has happened. Like Python has got stuck in my machine. Like it has got corrupted. I need to go with the reinstallation of Python. But I'll tell you like the theoretical concepts now. Maybe in tomorrow class, like I can give you the practical demo of like what's actually happening in this. Okay, like using this my Matplotlib, like I'll give you a practical example with this thing itself. Like here itself you can understand like what's actually happening. Okay, so these are like x coordinates, like a 0, 6 and 0, 250. For example, how does it get plot means 0, 0, like a first, this will be considered as x1, y1, x2, y2, like it will plot in the graph. Like this is how it will work. And these are like a plot functionalities and y points, the same like which we saw in the last page. And these are nothing but markers. Like markers concepts are like making it as visible. For example, the point which we are going to mark are like yes, if it is 3, like if we don't mention like x points, x coordinate means it will consider as either 0, 1, 2, like that. So 0, 3, then comes 1, 8, then comes 1, 1, sorry, 2, 1, then comes 3, 10. So like it will mark the coordinates of these points as with O. O means dot symbol. If you make it as asterisk means it will mark with the asterisk. For example, I'll show you here. If you want to make it asterisk. See, now the shape of the marker has got changed. Similarly, we have got each and every symbol for those markers. Then this is line graph. Line graph is the same as, I mean, it will be like a hyphen kind of thing, like a series of hyphens. Then if you want to create a label for that, yeah, this, I mean, a label for the scales. For example, x-axis should be mentioned as average pulse. The y-axis should be mentioned as calorie burnage, like how much calories you have burned for the same number of pulse. Then comes grid. Grid is nothing but look, for example, if you want to make sure with respect to this thing, grid. Grid means like scales. Like in the graph sheet, we can see the lines, right? It will be intersecting each other, such an intersecting line. Then comes subplot. For example, if you want to see the graphs for two different variables with respect to a common variable at the same time, I mean simultaneously, then you can make it like this. For example, within the same thing. For I'll show you. Sys Matplotlib. Okay. So z equal to np dot array. Let us take it 2, 4, 6, 8. So these are the variables which we have got taken into consideration. In this case, if I want to compare behavior of x and y with respect to z. So in that case, how should I plot plot of x comma z, and here y comma z. See, so this is how the graph behaves. This is like a x comma y, and this is x comma z. I mean, this is the behavior of x with respect to z, sorry, y with respect to z, and this is the behavior of x with respect to z. So we can come to a conclusion like x and z are directly proportional to each other. Like whenever the value of x increases, the value of y is also increasing. But here the condition is differing, like it is not directly proportional. It actually inverse, I mean not inversely, maybe differently proportional. Okay, scatters are nothing but plotting the points in the graph, it is just going to plot the points in the graph. Okay, now we can even try with bar. Bar is nothing but bar chart. See here, like in this case, we can also have go ahead with histograms and pie charts. And in this case, like if you want to have some other conditions, like for example, I want to plt dot pie following by for example, I want to take pi of z comma label equal to x. I'll keep the value of labels as x. Now let me try to show this to you. Let me check like how it behaves here. Okay, labels. So if you see here, okay, so I would like to add the labels here. Right? Okay, so like you can see the labels here, and we have some other properties like splitting out the particular pi alone out. Explore equal to explore. These are actually options, like what are the options available for that particular chart. I'll tell you like from where we need to get those options. Explore. Okay, so like these are all the available options. Like we can change the label, we can change the color, then we can change the starting angle. Starting angle in the sense like if you, I'll tell you like okay. So here we haven't defined the starting angle. If we want the pi to be starting from here, then it will move ahead, move a little bit away here. Similarly, it will go the adjustment. We can make the adjustments using that angle, start angle option. Then radius, we can change the radius like this. To 1. If it is radius equal to 1, then the size will be okay. I think it is not loading. So the radius is 1. If I keep increasing the radius size, see the size of the graph, pi has got increased. So 1 should be fine, I guess. Okay. So equal to so we have 4 elements. So just the 4 should be fine. Okay. So it has moved away from the pi. Instead of making it as 2, let me make it as 1. Let me see like how it behaves. Okay, 1 is also too large distance. Let me 0.75. If it is 0.50, Okay, so like these are the available options. Similarly, for each and every graph type or chart type, we have a number of options which we can use, like markers, labels, color, font size, and those things. So like these are the existing functionalities that are available in Matplotlib. Okay. So like next one is Seaborn. As I already said, like Seaborn is actually similar to that of a CSS styling thing. Like it works on top of Matlab. Like basic functionalities of Matlabs are inherited within the Seaborn, but a few more additional concepts that are not concept features. The features that are available in Seaborn are, like styling, the way in which it looks. To be simple, like it improves the look and feel of the graphical representation. Then it has a functionality of supporting multi-plot grid. Multi-plot grid in the sense like it can categorize. Okay, for example, like I'll tell you like how it categorizes those things. Supports multi-plot grid. Estimates and plots linear regression automatically. Better comparison. Variables. Okay. Okay. So let us go to this. So here I don't have option to edit. Okay, no issues. I'll tell you like how it works. Let me explain this thing. Okay, so it will also include all these libraries, like whichever we need to use. Then here we'll be getting the data through the Seaborn library itself. Like we'll be storing the value of the data. Like for example, this flights is actually nothing but data which we get from a GitHub. Okay. Say from here we can get a data set. These are the sample data sets which we are using for testing purpose or learning purpose. Like for example, I need the data from this thing, flights.csv. You can see all the data here. From this data can be used for learning purpose. Based on this data, I'm going to get the this thing. For example, if you make it as a SNS rel plot, it will be plotting the data in the form of scattered this thing. Rel plot. Okay, so it will allow only basic Python executions. It's not allow packages. Fine. So like if you see here, it will be showing the output like this. For example, also be able to edit these things. Fine. Set string equal to text. Okay, this will be loading the data set of this tips. Control F. Okay, it will collect the data from the tips CSV, and it will get those data, and x is equal to total hyphen bill. I mean total underscore bill. This column will be considered as x. Y is tip. This column will be considered as x, and this column will be considered as y. So like how it will work, it will look means, for example, x equal to 15.99 comma 10.34 comma, like that it will goes on. Then comes y. Not 1.01 comma 3.5, like that it continues. So it will be collecting all those values and it will be plotting the values here. The first value is like 16,99, 1,0. X value is 16,99 means it will come somewhere here to 1,2. Means this one. This is the value like which is plotted for this coordinate. By default, this rel plot functionality is used to make it as a scatter plot. It will be plotting. It will just plot. It will not connect those plots. I mean, it will not create in lines and all. Okay, then comes a cat plot. Cat plot is nothing but a categorization plot. I'll show you here. These are the, what to say, like parameters that can be used in cat plot method. This, similar way it is collecting the data from this load data set from this exercise, and it is going to plot x equal to time, y equal to time, hue is equal to kind. Like a kind hue option is like showing this thing, like categories. For example, I'm going to consider rest, taking rest, making walking and making running as the conditions means. Not conditions, like category. If we keep taking rest, like this much amount of calories will get burned at this pulse. For example, if you're taking rest at 1 minute, this much amount of pulse might happen. And if you're walking and for 15 minutes, then this amount of pulse might happen. And if you're running for 30 minutes, then this kind of pulses might happen. Like that, it will help us to categorize. Yes, then comes facet grid. Yes. So here you can find after getting data from this tips, from the tips CSV, like it will categorize with respect to this column value. This column is like a time. If time is equal to dinner and lunch. Yes, here dinner and here lunch. These are the two types of values. Based on this column, it will calculate, I mean, it's divide like a facet. Facet is nothing but of taking a frame and subdividing with itself. For example, how many distinct values that are available in a column. Here, with respect to time, we have only two distinct values. One is like lunch, and the another one is dinner. Based on those two values, it will plot the values here. Here it is showing in terms of hist. If you want to show in terms of scatter, then you can go for scatter. If you want to go in terms of pi, then you can go in. So no, pi will work only for one variable. And if you can go ahead with bar and line, those things. And this map will come along with facet. I mean, if you, whenever you're going to go ahead with the facet grid, then obviously map will come intact with that. And the basic parameters of this map functionality includes like PLT scatter. I mean, these are X and Y coordinates. This is an object which we get from here. I mean, based on this information. I mean, whatever the type of visualization which are going ahead with, and these are like coordinates X and Y, something like that. So like these are the things which we can come across with data visualization stuffs in Python. And okay, so like a comparison with ETL and tailor-made tools. I mean, for example, we have many ETL tools and data visualization tools in the market, like Tableau, RapidMiner, Informatica, Talent, those things. But what is the advantage, I mean, difference between those tools and this visualization using Python? This Python is actually not a well-formed tool for data visualization. It will give you a primitive level of data visualization, like which a person who is having idea in a data analysis or can understand. Like it does not give you an in-depth information about the data. For example, if you we have created such visualizations here, but still if you want to see the visualization for an expanded period of time, for example, instead of 10 years, if you want to see the data for 120 months, then we can't see that. The reason is like the graph, I mean, the visualization created here is a static one and it is not a dynamic one. It cannot be interacted with. But such interactions can be made in other ETL tools like Tableau, those things and all. Then these are like these are not tailor-made tools. Like these are developed for the data scientist people. Like if they want to check they will be utilizing, I mean, they'll be creating such algorithms. I mean, they might be using many algorithms like RNN, CNN, and those things. While implementing such algorithms, they might plot a graph. And if they find at any point of time, like their graph is intact with the exact data source, then they will go ahead with such algorithms in evaluating the data. But in ETLs, like it will be by default, we can just adopt those algorithms. Here we need to create our own, I mean, not create, but we need to program by ourselves. Like it is not a ready-made thing, we need to do it by ourselves. So like this ETL tools like can be used by data scientist, not by an end user, because like end user will just have them for static details. They can't interact with the visualization to a greater extent. Then like from a techie's perspective, like a techie perspective is nothing but a person who is well versed in Python can go ahead with this data visualization, because you need not go ahead, I mean, you need not prefer, I mean, you in the sense like end user or a non-technical person need not prefer for this Python based visualization, but they can be given with this visualization if they are okay with static visualization. Like if they don't want to interact or if they don't want to further explore, they just want to see like what has happened. In that case, like they can go ahead with this concept. So like advantages of using this Python libraries is since I told like it is an open source, so it doesn't require any license or something, so it is free of cost, so it will be like a cheaper approach. Then comes quicker analysis. Like usually if you're going towards any such tools like a Tableau and all, then there should be a data engineer who should process the data. Like they need to extract the data from the data source. Here it is a Excel file. There they might be using any number of data sources like Excel file, database table, XML file, etc. They need to extract the data from that. After that, they need to do some transform operation, like processing the data. After that process, they need to load the data into the proper data source. From the data source, only Tableau can collect the data, and then they can do further process. Then instant interpretation for data science. Data scientists need not require actually Tableau, those things and all, because since they have adequate knowledge in Python programming and also in algorithm concepts, they can implement any such algorithm and they can find out like what is the actual thing that is happening in the data source. So like it will be a quicker process for them instead of going with the Tableau and depending on those things and all. I mean, but it also have some few disadvantages. It cannot make some complex logics. If you want to make such complex logics in the visualization, then you need to again do it in the coding. Like you can't just rely on the existing functions that are available in the libraries, because even in the market, like such ETL tools are built on top of Python along with some other languages, because they want to make sure like a end user does not go with the further customization. They just want to make sure like end user just uses their own methods that are existing in the tools. So here in while using Python, like we need to write more number of codes, obviously, so it is creating code dependency and complexity. And also like here, since as I mentioned, like a static event is being pertained here, like interaction is not that much possible. So like this is all about data visualization using Matplotlib and Seaborn. And once again, like unfortunately I couldn't show you good enough practical exposures. Like just now it has got this Python has got corrupted in my machine. By tomorrow I'll try to show you all this practical examples, like after fixing this. Is it clear for everyone?
Participants can ask their doubts